Routing with OSPF Part 2. Hopefully you're rolling right into this from the previous nugget, because I am. It's still all fresh in my mind. So I just want to finish this thing up. It's rocking so far. We've got OSPF configured in a base sense, meaning switch 1, router 1, and both the branch and corporate offices are receiving that. Now it's time to get fancy. We left off in the lab. We did the testing, verified the neighbors had formed, we verified the routes were appearing on the devices, and now we can get into the new stuff. Now, I want to mention, again, for those people that are focused on only the CCNA exam, the stuff I'm going to talk about here probably is not on the current CCNA exam, but it may be in the future. I don't know. Cisco revises it all the time, so I could see some of these things trickling in. So, first thing is advertising a default route from both routers, meaning now that we've got OSPF configured, we don't want to have to go to every device. Now, I know it's only 2 devices in our small little lab here, but we don't want to have to go to every device and say, oh, you have a default route. Go that way. You have a default route. Go that way. And just, configure everything. Oh, you got a default route. So instead, these guys both have a default route to the internet. So why not have them advertise that to these guys using OSPF? And then we can remove the static, well, I mean, usually we wouldn't have it in the first place, but you can now remove the static route coming from there. So looking at the objectives, that's the goal, is to remove the static route from branch 1, switch 1, and corporate switch 1. And then advertise or configure router 1 in both offices to advertise the default route. Notice my keyword here, unconditionally. I'll explain that when we do it. To both switches in the offices, and then verify the OSPF route now exists on both layer 3 switches. So let's take out this objective first. I'm going to bring up my secure CRT connection to, let's see, switch 1. So I'm on switch 1 right now in the branch office. Let's do a SHA IP route. There's my static route. We're going to yank that one out of there. We want to do that on both of them. Quickest way to do that is do a show run include IP route, because we know that's what the command starts with. There it is. Then do no. Just paste that bad boy in there. Gone. Show IP route. So we've got nothing now. No default route. Notice it says gateway of last resort is not set. So now our pings to the internet will fail because the switch doesn't know where to send it. So let's go over to the corporate switch 1, do the same thing. Show IP route. It's seeing all of the routes from the branch office. Show run include IP route. There's our static route right there we want to yank. Going to global, no, and this guy. Gone. Show IP route. Gateway of last resort is not set. He can also not ping to the internet. So now here's how we do it. You go to the, let's start with the branch office because that's where we started. You go to the branch office, and the first thing I want to do is verify that this guy does indeed have that default route. He does. That's to our internet service provider. He is still able to ping to the internet. So we need to tell him to advertise that route to all of its neighbors, all of the devices. So I'm going to go in here and type in router OSPF. If I can type it, 1. And here's the command. It's just one command. Default information, or actually default dash information originate. Hit the question mark. What this command does is say, this tells the router, if you have a default route, send it to your neighbors. So router 1, let's go back to the canvas here. Router 1, if you have a default route, which it does, go ahead and send it to the neighbor. And that would work. That would solve it. However, the lab was very explicitly to say, advertise the default route unconditionally. What does that italics unconditionally, what's that looking for? Well, what that's after is this. Always advertise the default route. See, this command right here says advertise the default route if you have a default route to all of your neighbors. Once you tag this one on, it says advertise the default route even if you don't have a default route. Just pretend that you do and send it to the neighbors. You might say, well, why would you do that? Well, because Maybe you've got a BGP connection with the ISP and you're actually receiving the whole internet routing table. You wouldn't have a default route, or you may not have a default route at that point. Or maybe you just want the network stability. If something with the, maybe you have a flapping internet connection, you don't want a bunch of OSPF updates saying it's up, it's down, it's up, it's down, flooding your network. You just want it to stay stable because, hey, keep the default route, everybody will come here, and if it's down, it's going to get dropped anyway, so might as well keep it there. So now when I hit the enter key on that one command, I can come over here to branch 1, switch 1. Let's do a show IP route. And look at that. OSPF, it's identifying that as an external route, and it's also putting a little star there to say that's my candidate default route. Notice this output has changed as well, saying I now have a gateway of last resort. So that was received. It is now that default route going out FAs 1/15. Now, it's something that may be running through your mind. You might say, okay, default information originate always. Always. Sending the default route to the neighbors, okay, isn't this branch 1 router 1 going to send that default route to corporate router 1? Isn't that going to happen? If it's sending it to all its neighbors, won't it be sending its default route over there? Short answer is yeah, it actually is. Whoa, wait a second. So wouldn't he then set his gateway of last resort to point to him, and now you're kind of like stuck? No. And the reason why is because, remember, corporate router 1 already has a default route with a really good administrative distance, 1. This guy's coming in. Let's look at switch 1. He's coming in and saying, oh, I've got a default route. It's got an admin distance of 110. Router 1's coming back and saying, sorry, beat that, buddy. I got a 1. You remember, administrative distance lower is always better. The static route's more believable, so it's not going to believe it. But we do still have to go over to corporate router 1 and instruct it to do the same thing. Router OSPF 1, default information originate always. Enter. And now we can verify and go over to corporate switch 1 over here, show IP route. It now has that default route. It just received it. It's sitting in place. And now we should be able to ping out to the internet from both sides without a problem because our default route has been solved. So now we can look at our next objective. This is where it gets fun, and I know, this is outside the CCNA objectives, but come on, it's too easy. Once you see it, you're going to be like, why wasn't that should be part of the exam? I'm sure you'll agree. So it says on the ABR, the OSPF area border router, configure two-way summarization. So whoa, stop there. Who is the ABR? He is. Remember in the last nugget, oh, my pen got very fat. The last nugget, we said he has these interfaces going to area 0, and these interfaces, I kind of like it. These interfaces are going to area 1. That makes him the ABR. And in OSPF, the ABR is one of the only routers that have the ability to summarize. This router, sure, it's running OSPF, cannot do a bit of summarization. Why? Not an ABR. That's one of the requirements. It's one of the painful things with OSPF is it has a lot of design constraints with that. So if we want to do this, again, it's going to be one command. Hang on, let's look at the lab to make sure if we do it, we're going to do it right. It says the corporate office should summarize all internal Area 0 networks into a single route when advertising to other OSPF areas. Devices internal to the corporate office should receive a summarized branch office route representing all the internal branch office networks, with the exception of the 10.1.254.0/30 link between corporate 1, switch 1, and router 1. This is kind of funny. This right here, you remember, we created 10.1.254.0/30. Right? This side, I can't even remember which is which. So like this is .1, this is .2, or maybe vice versa. I don't know which. But it's a little point-to-point kind of quasi-WAN link, if you will, between the layer 3 switch and the router that they're kind of using for their neighbor relationship, they're using for communication. And when I initially laid out the scheme, laid out the IP addressing scheme, it seemed like a good idea, right? Well, not so much anymore. Because look at this, we've got all these VLANs over here. I go back to our port spreadsheet. Right here, we've got all these VLANs, which summarize very nicely into this little branch 1 summary route right here, 10.1.64.0/21. That's nice, except for that guy. It seemed like, oh, well, that's a good idea. Let's make it 254 so we can really tell it's like way out there. But this is how you end up with unsummarizable network. So guys, I did this on purpose to show the drawbacks of just pulling subnets out of the air. Actually, I didn't do that on purpose, but that's how easy it is to now leave yourself in a place where I can't summarize that. It's not possible. So if this were me, if I were cleanly doing this, I would probably go back and change that to a subnet that fits in some kind of summary route I can generate for here. But it's not me. I've got to stick to the lab, which some guy wrote. So let's do it. We're going to create a summary route for both the corporate and the branch office. So here's how it's going to fly. It's actually, again, one command for each side. It's really easy. I'm going to go to the router 1. Because he is our ABR. Again, let's do a show run. Let's do section router OSPF. And under this section, I can see that I've got this side in area 0 and this side in area 1. So this actually makes this side really easy, since the network statement really matches what our summary should be. So hang on, I want to watch it work. I'm going to go to branch 1 switch 1. Let's do a show IP route. Actually, I just did right above there. And I see all of these specific subnets coming from area 0. These are the subnets of the corporate office. So I'm going to go back to corporate router 1, router OSPF, and here's the command. Area 0 range, you can see right here, range, summarize routes matching address and mask, border routers only. So I've got area 0 range, and then I'm going to type in 10.1.0.0, and our subnet mask, it's not a wildcard mask, it says subnet mask, IP mask, 255.255, and I'll go back up here. Yeah, where are we? I'll look at my corporate, right there. There's our summary mask. 255.255.192.0. 192.0. And hit the enter key. That's it. Really. What I've said is area 0 is represented by the range 10.1.0.0 with a mask 255.255.192.0. That's the range that represents this. And that tells the ABR, okay, advertise that range to all other areas. Now, this is only connected to one other area, but eventually somewhere down the road it might be connected to others, maybe area 2 and so on. Advertise that range to the other areas and suppress the more specific routes. So check this out. Let's watch it work. I'm going to go back to branch 1, switch 1. We just verified that was there. Let's hit the up arrow, do a show IP route. Whoo, Nelly. Look at that. 10.1.0.0/18. We now have a summary route, and all the more specific routes are suppressed. Because again, remember, the bigger your routing table, the slower your router. It's just a fact of life. So the more you can summarize, the more you can squish it down, the better off you are. So let's do the other direction now. I've got the switch 1 at the corporate office, which still has all of these more specific routes from the branch office. And the lab said, go ahead and create a summary route that encompasses all of those, a single summarized branch office routes, all of those into a single advertisement, with the exception of the .254, which is that guy. Stupid network architect. So I'm going to go back over here to the corporate. Let's do corporate router 1. He's our ABR. One more command. Area 1 range. 10.1. Let's bring my port spreadsheet over here. 10.1.64.0, and there it's I've documented my summary mask right there. I'll just copy that to my clipboard. 10.1.64.0, and just paste my summary mask in there. Which again, this is the range that represents that all offices in, or all subnets in area 1. Sometimes I just listen to myself talk, and I'm like, how do you guys listen to me? I'm like, all bubblegum, high in the air. Okay, let's look. So let's do show IP route. Thank you for your patience. Show IP route. Oh, look at that. That was even a preemptive. As it was scrolling, I was like, oh, I know it's going to look good. Look at that. We've got an interior route. All of these routes are all suppressed. They're all squished down. Actually, even this guy included. The only one left is our goofy 254 because it doesn't fit in there. But we've definitely shrunk down the routing table a decent amount. I'd say cut it down by about half, which is great. So now we've got two big objectives done there. We've got default route advertising, and we've got two-way summarization configured. Last piece is now to optimize OSPF. Two pieces to this. Number one, ensure that the corporate router 1 and branch router 1 become the designated OSPF router for their respective Ethernet segments. The switches should be exempted from the DR election completely. Okay, what's that? What's a DR? Well, let me clear off this chicken scratch here and just do a quick explanation. It's actually a pretty simple, easy, cool concept. When you have a bunch of routers on an Ethernet segment, let's say you've got this line represents a switch. Well, here, just to make it easier, here's a switch. You've got a whole bunch of routers plugged into that, and maybe this is kind of like your hub, and these are OSPF routers connecting off to all the different places of the network. They would, without this concept of the DR, they would all form full neighbor relationships, which seems fine. They'll all be like, hey, let's be a neighbor, let's be a neighbor, let's be a neighbor, all that kind of stuff. Seems fine until you have, let's say, a network outage. Let's say this goes down. This guy will say to all of his neighbors, he'll be like, hey, everybody, my network went down. And OSPF is set up in such a way that when neighbors receive an update, they'll pass it to all their neighbors. So they all turn around. Let's use a different color here. They turn around like this guy's going to be like, hey, everybody, I just got an update. Network's down. This guy turns around, hey, everybody, network's down. It's like this, just scribble just to make it look crazier. It's like this big fireworks storm. It's like 4th of July, fireworks going off where everybody's talking to everybody. So, well, I was going to say Cisco, but it's not Cisco. It was Dijkstra, the genius who created OSPF, said, whoa, we're not going to do that. Instead of having everybody form full neighbor relationships, what we're going to do is we're going to elect at the very beginning a DR and a BDR. Can't write as well with my fat pen here. My DR and a BDR. So these guys will form full relationships with both of them. That's the designated router and backup designated router. And when something goes bad, let's say this WAN link goes down, he's going to say, hey, DR, BDR, I've got an update for you. DR, BDR says, okay, I got it. Let me send that to everybody else. And everybody else goes, okay, got it. Let's move on from there. So no fireworks storm. It's kind of like, think of them as like a manager for the segment. They're just kind of traffic control. They're like a hall monitor, just being like, all right, everybody slow down. Just bring everything to me and I'll disseminate it to the whole company. It's kind of like, think of email blasts. Like, if everybody at your office always sent everything to everybody, they just said, let's send this email to everybody and then just kind of let it disseminate down from there. It would just be a mess. Everybody get flooded with email. But instead, they send it to management. Management says, okay, let's put this all together into a newsletter or something and then send it to everybody else. So that's kind of how it works. So these guys only form what's called two-way relationships between each other. So that's how it all works out. Now what I'm saying, that's the concept. What I'm saying is let's apply that and make this and this the DR. These guys should never become the DR. That was a very explicit statement. So these guys must always remain nothings in the network. So the way we'll do that is using just one command under each device. Let's go over here to let's see, we're on router 1. Let's see, where am I? DR is a per interface thing. So for example, and let me just mention this one more on the concepts. This Ethernet segment that's getting really messy is one segment. Everybody is connected to this one segment. There will be a DR and a BDR for that. But let's say over here, let's say this guy connects onto another Ethernet segment with a couple routers. This is another one. So there will be a DR and a BDR for that. So maybe this guy is the DR for this one, and this guy is the DR for this one. Can you see through all my chicken scratch? So it is a per segment thing. So it's okay to have, this router 1 and this router 1 be DR. It's not a conflict. He's the DR for this Ethernet segment. He's the DR for this Ethernet segment. Okay. So with that being said, it's a per interface thing. So I'm going to go to, let's start off on the branch router 1 and go under the interface that connects to the switch. So I'm going to do interface FA0/0, and I'll do IP OSPF priority. And actually, you know what? This is open for debate because the default priority is 1 for everything. So all devices have a priority of 1. So let me actually, before I even do anything, I'll do a show IP OSPF neighbor. And you can see that we've got the let's see, we've got, where am I? Right here. It looks like, from router 1's perspective, 10.1.254.1 is the DR of the segment. So the switch is currently the DR of the segment right now. It also sees across the internet, the corporate router on the other side is the BDR. So if we were labeling all this on the picture, I could put this together and say, okay, on this segment, he's the DR, so that must make him the BDR, which is not what we want. On this segment, he's showing up as the BDR, which must make him the DR, because there's another Ethernet segment. So we don't really care about this. We just care about this side. So what I'm going to do is go under here, and I'm going to do IP OSPF priority. And let's just say 50. Higher your priority, the better off you are on the election. 0 means you are exempted from the election. And that's why I'm saying this one is open to interpretation, is because it says the switches should be exempted from the DR election completely. Well, if they're exempt, then we could have left the priority as 1 on router 1, and that would work just fine. But, I set it to 50 just for, I guess, double protection. So let's go over here to branch 1, switch 1. Let's exempt him completely. We'll go under interface FA1/15, which is what connects to router 1, and do IP OSPF priority. And let's do 0. So he is now completely exempted from that election. So we'll do a show IP OSPF neighbors from his perspective, and notice the router 1 has now jumped over as the DR. If I go back to router 1, do the same command, you notice this guy has become a druther. It's actually short for DR other, meaning it's not a DR, it's not a BDR, it's something other than that. So every router that's not the DR or BDR shows up as, I always say, druther. But that has now changed from before, where the switch was the DR. So that's one side of the connection. Let's go to the other one. On the corporate side, let's go into, just get the interfaces laid out in front of me. I'll go into interface FA0/1.1, which connects to switch 1. That's the only one that's actually being used. The other ones are passive. And I will do IP OSPF priority 50. And again, if you didn't choose 50, if you did this lab on your own and you didn't choose 50, that's okay. You may not have chose anything. You may have just gone into the switch side. I'm on the corporate switch. Let's do interface VLAN 1, and on him I'll do IP OSPF priority 0. And just doing that would solve both objectives, actually. I just did 50 for fun. So now I can go back and do a show IP OSPF neighbor. Now from the corporate router, we see the switch showing up as a druther as well. It's no longer I think before it was the, actually I don't even think we checked it on the side, but before it was either a BDR or a DR, but that's showing up correctly. Good. Second objective to optimize OSPF is to use an OSPF hello timer of 1 second between all OSPF neighbors. Well, good grief, I should have read this, because that's also under interface config mode. But by default, it really depends on the type of network you're connected to, but I'll do a show IP OSPF interface. All of these interfaces will have a 10-second hello timer, which means they'll wait 40 seconds before they considered a network down. Maybe 10 years ago that would have been like, okay, we can handle a 40-second outage, but nowadays with voice over IP, all that kind of stuff going on, people are like, we got to go faster. So what we can do, by the way, we can even go sub-second with the OSPF timers, like millisecond kind of ranges, which gets fun. But the lab said set it to 1 second. So I'm going to go into router 1, go back into the interface, FA 0 slash, well, yeah, we've got one interface here. Let's do fast Ethernet 0/0 first. Just paste that in. Which is the neighbor over the cloud. That's the MPLS or the internet connection neighbor that we formed. And I'll do IP OSPF hello interval, and we can set it to a setting of, we'll do 1 second and put it in there. So we've got a hello interval of 1 second. I'm also going to go into interface fast Ethernet 0/0.1 and do IP OSPF hello interval 1 second there as well. Now you notice when I'm doing this, neighbors are going down. Neighbors are dying. Oh, that just totally fried my train of thought. The doorbell rang. I had to go get the door. Did you hear that? I don't know if that came through on the mic, but I'll tell you what, it just came. I'm rather excited. Check this out. You know, all the new laptops nowadays are serial portless. I'm sorry, but I'm doing multiple things at once. They don't have serial ports anymore, so you have to go buy a USB to serial converter. Well, Monoprice, my favorite place to buy network cables. One day I was just actually just recently I just said, I wonder if they have USB to serial converters, and I searched and they do. And it's only, which one did I get? This one. Look at that. $5.54. I paid $30 for mine before, so I just ordered a bunch of these guys off of Monoprice. By the way, if I should get kickbacks from Monoprice. I tell everybody about this place because they have. I mean, there's cheap cables and then there's cheap cables. I mean, look at this. You got. Like I ordered some for a network rollout I'm doing on Friday. A couple days from now. And look at this, 55 cents for these little patch cables. I mean, these are really professional crimp cables. They got every color. I actually have purple cables in my bag. Purple cables, I tell you. So anyway, they're really cheap. Really good quality. They're in California, which is right next to me, so their overnight shipping is dirt cheap. So anyway, hello intervals. The hello interval is set to 1, and you notice as I'm doing this, my neighbors are dying. And that's because the hello interval has to match. It's part of the hello packet. If it doesn't match, it'll say, sorry, we're not compatible. We're going down. So I've got corporate router 1 fixed up with the right hello interval. Let's do corporate switch 1, interface VLAN 1, IP OSPF hello interval, and we'll set that to 1 second as well. Neighbors restored. That's good. Now look at this. Hang on. Let's go back to corporate router 1. It automatically adjusts the dead interval. So okay, these are all passive. I mean, they're not really being used. So right here is our ones where we start tweaking. Look at this. Hello interval of 1 second. Dead interval has now adjusted down to 4 seconds. OSPF always makes it 4 times the hello timer. So right there you can see that we're now running updated hello timers on both those guys. Same thing with the corporate switch. If we were to do a show IP OSPF interface, let's just do VLAN 1. We see the hello timer is corrected. So now it's as easy as going to these other guys. Let's go into, let's do interface FA 0/0 and do IP OSPF hello interval 1. Let's do 0/1, hello interval 1. That's the branch router. And then let's go to the branch switch right there. FA 1/15, IP OSPF hello interval 1. That should be the only one. Good. And we see our neighbors coming back up. Show IP route. We should see all of our happily summarized routes that are being received. Our external route being advertised. Hello interval of 1 second. Guys, I think we've got it. So let me put all these in the answer key and just put the whole thing in together in one picture. Okay, here it is. I got it all finally put together. Between this nugget and the last one, we went through. It did a lot of stuff. A base OSPF configuration, laid out the router IDs, specific network commands, got the message digest configuration authentication going on all devices, and that's really was the last nugget. When we got into this one, I called it the fancy OSPF configuration. We went into the routers, had them originate a default route, set up router 1 as a true ABR, that is, he's doing summarization of all of those routes. between the different areas, modified the priority so he's always the DR, and adjusted the hello intervals on all the devices so that we're able to see that. And you can go down, you see the switches, remove the default route because now they receive it via OSPF, set their priority so they never become the DR. Yeah, this is just going down this list. This is good stuff. I'm going to save this, bundle it up, and we are good to go with OSPF. So I hope this has been informative for you, and I'd like to thank you for viewing.